In this video, we're going to talk about adding and subtracting rational expressions. When we add or subtract rational expressions, we need to find the lowest common denominator. Let's talk about the method for finding the lowest common denominator. First, we fully factor all denominators. For each individual factor in a denominator, determine how many times that factor appears in each denominator. That factor will appear in the lowest common denominator the greatest number of times that it appears in any individual denominator. So for instance, if we wanted to add the following rational expressions, what we could do is think of the denominator of x as simply x, but then think of the denominator x cubed as x times x times x. Now, when you get pretty swift with this, you don't actually have to spread them out like that. But for an initial attempt, let's think of it that way. Now, the only factor from the denominators is x. It appears in the first denominator once, and it appears in the second denominator 3 times. So we have to choose between 1 time and 3 times, which is bigger. Well, the largest value between the number 1 and 3 is 3. So what that means is the factor x will occur 3 times in the lowest common denominator. Sometimes students make the mistake of adding them and they'll say, okay, it appears once in the first denominator, 3 times in the second denominator. It should appear 4 times in the lowest common denominator. That's wrong. It's whatever the biggest of those options is. So the lowest common denominator will be x cubed. So what we're going to do next is put each rational expression over the denominator of x cubed. So the denominator of x, the one you see in red, is multiplied by x squared to become x cubed. So since we multiplied the first denominator, which was x, by x squared to get x cubed, we're going to do the same thing to the numerator of that rational expression. Now, I find it very, very helpful to put the denominators down first. If you notice here, after finding the lowest common denominator and saying that it's x cubed, I rewrote each rational expression, but only the denominator part, and I put that lowest common denominator under each one. And now what I'm going to do is ask myself, if I multiplied x by x squared to get x cubed, what should I multiply 3 by? And the answer is x squared, because whatever you multiply the denominator of in a particular rational expression, you need to multiply the numerator by the same thing. So 3 times x squared becomes 3x squared. Now, let's look at the next one. The next one was x cubed. Well, the denominator of x cubed was unchanged from the first rational expression to the second rational expression, so the corresponding numerator will also remain unchanged. It will be 5. Next, what we're going to do is add the numerators over the common denominator and simplify if possible. So we have essentially just 3x squared plus 5 all over a denominator of x cubed. And then we state our restrictions. If the denominator is x cubed, x cannot equal 0. Okay. Now let's try another one. We have 2x over x squared minus 9 plus x minus 6 over 2x squared plus 12x plus 16 minus the rational expression of x plus 4 over 3x. Well, what we're going to do is factor each denominator. So you'll see here that the denominator of x squared minus 9 becomes, after being factored, x minus 3x plus 3. The denominator of 2x squared plus 12x plus 16, after a couple of steps, I actually jumped the gun a little bit, but it's 2 times x minus 3 times, 2 times x plus 3 times x plus 3. Let me erase that for a second and point you back at the bottom line. So x squared minus 9 becomes x minus 3x plus 3. 2x squared plus 12x plus 18 at first becomes 2 times x squared plus 6x plus 9, but then becomes 2 times x plus 3 times x plus 3. And finally, a denominator of 3x can be thought of as the factor 3 times the factor x. Okay. Now, let's talk about what the lowest common denominator should be. When I look at those denominators, I see we've got a factor of x minus 3 here. So I'm going to consider that one type of factor. I have a factor of x plus 3 here, and here, and here. Just for the time being, I'm just going to think of it as just the factor x plus 3. I've got the factor 2 right there. I've got the factor 3 right there, and I've got the factor x right there. So in essence, I have 5 different types of factors: x minus 3's, x plus 3's, 2's, 3's, and x's. Now, the factor x minus 3 we're going to look at specifically. It occurs once in the first denominator. It says here once in the second denominator, but that's actually incorrect. It occurs 0 times in the second denominator, and it occurs 0 times in the third denominator. So since x minus 3, its occurrences are 1 and 0 and 0. It says here 1 and 1 and 0, but it's really 1 and 0 and 0. Since the frequency of occurrence in the denominators is 1 and 0 and 0, we take the largest of those values, and the largest value of 1 and 0 and 0 is 1. So the factor x minus 3 should appear one time in the lowest common denominator. So we're starting to build our lowest common denominator, and we know it's going to be x minus 3 to the 1. Of course, we don't have to show an exponent of 1. Now let's look at the factor x plus 3. Well, the factor x plus 3 occurs once in the first denominator. It actually occurs twice in the second denominator, and it occurs 0 times in the third denominator. So the frequencies are 1 and 2 and 0. The largest of those values is 2. So therefore the factor x plus 3 should appear twice in the lowest common denominator. So we start building our LCD, and it looks like this so far: x minus 3, x plus 3, x plus 3. We're not done though. So we keep on going. Let me just recap what we have so far: x minus 3, x plus 3, x plus 3. Now, let's look at the factor 2. The factor 2 never occurs in the first denominator, but it does occur once in the second denominator, but never in the third one. So 0, 1, and 0, the largest of those values is 1. So therefore the factor 2 should appear one time in the lowest common denominator. So we can put a 2 there. Now let's talk about the factor 3. Now don't think about 3 as the term 3 in terms of x minus 3 and x plus 3, because in the factors x minus 3 and x plus 3, 3 is not a factor. It's simply a term within that factor. The only time 3 is actually a factor is in that third denominator. So the first denominator contains no factors of 3. The second denominator contains no factors of 3. But the third denominator contains one factor of 3. Now the largest value of 0 and 0 and 1 is 1. So therefore the factor 3 should appear one time in our lowest common denominator. So we put it down. Okay. And we're almost done our denominator analysis. What I'll do first is I'll just put what we have so far as our LCD. And finally, we're going to look at the factor x. Now, again, we're not looking at x in the x minus 3 or the x plus 3, because in those factors, x is merely a term. It's not a factor. The only time x actually appears as a factor is in denominator 3. So the factor x occurs 0 times in the first denominator, 0 times in the second denominator, and 1 time in the third. The largest value of 0 and 0 and 1 is 1, so the factor x will occur once in the lowest common denominator. So putting all that together, we have our denominator up at the top. Well, what we can do is say this last part here, that's just 2 times 3 times x, that's 6x. And then we have a couple of factors of x plus 3, so that's x plus 3 quantity squared. And then we've got a lone factor of x minus 3, so we've got x minus 3. And that is actually our LCD. So now that we know that our lowest common denominator is 6x, x plus 3 quantity squared, x minus 3 quantity, we should put each of our 3 rational expressions over that common denominator. Then we can figure out the numerator for each rational expression. And we're going to do that by determining whatever new factors were introduced to each denominator, and then introducing those same new factors to the corresponding numerator. to say introduce a new factor is the same as saying to multiply. So what we're really saying is, what did you multiply a particular denominator by to get the lowest common denominator? Multiply its numerator by the same thing. Okay, so we take let's look at our first denominator. It was x minus 3x plus 3. I see that we introduced a new factor of x plus 3 and a new factor of 6x. In other words, we multiplied the first denominator by 6x, x plus 3. So we're going to multiply our first numerator by 6x, x plus 3. Now let's look at our second one. We had 2 and x plus 3 and x plus 3. Well, in order to get from that first red denominator to the second one, we have to multiply by 3x and also by x minus 3. So we say we multiplied the second denominator by 3x, x minus 3. So we multiply it says first numerator, it should say second, by the same. And so when we do that, we get 3x and then x minus 3. And then we have the original, which was x minus 6. And then finally, we see the third denominator was 3x. In order to get the denominator of 6x, x plus 3 quantity squared, x minus 3, we must have multiplied by 2 x plus 3 quantity squared, x minus 3. So we're going to multiply x plus 4 by that same thing. And that's what we get. And now we're going to put all those numerators over the lowest common denominator. We're going to distribute and we're going to collect like terms. So this line here is just this last line. All we're doing is we're putting all of our numerators, like this plus sign, we're showing it as a plus sign, and this minus sign, we're showing it as a minus sign. That's it. And now what we're going to do is distribute. So 12x squared distributing in becomes 12x cubed plus 36x squared. Now, x minus 6 was multiplying. If you remember, that second numerator was 3x, and then it was x minus 6 and x minus 3. When we distribute out x minus 6 and x minus 3, we get x squared minus 9x plus 18. And now we're going to distribute in that 3x. Okay, so we're just distributing. Nothing too complicated here. And when we do that, we get this right here. Now that last one, that last numerator, that was a negative 2, and then it was an x plus 3 squared, and it was an x plus 4, and it was an x minus 3. When you distribute x plus 3 quantity squared, you get x squared plus 6x plus 9. When you distribute x plus 4 times x minus 3, you get x squared plus x minus 12. And so we're taking that negative 2. Oh, not yet though, actually. All we're doing now is we're just distributing here. Now, when you distribute all these, and I know it takes a while to do, doesn't it? But when you distribute all of those, what you end up getting is 9 terms. But then after you have those 9 terms and you collect like terms, you end up with this expression right here. So it takes a couple of lines to get to that expression. Now, what we're going to do, we're going to actually next take that negative 2 and we're going to distribute it in. So again, if you're patient with this, it takes time sometimes, a long one like this, but if you're patient and you just distribute it in, you'll get what you see here. And now you'll just collect your like terms. You've got negative 2x to the 4. Then you've got 12x cubed plus 3x cubed becomes 15x cubed minus 14x cubed, so you get positive 1x cubed. 36x squared minus 27x squared minus 6x squared becomes plus 3x squared. 54x plus 126x becomes 180x. And finally, we've got 216 on the end. And we still have our denominator. At this point, we see if we can factor the numerator and then simplify by crossing out like factors from the numerator and denominator. But in this case, we cannot factor the numerator, so we're not going to be able to simplify it this way. So we literally just leave it alone. And now we just determine restrictions. And from that denominator, we see x cannot equal 0 or negative 3 or positive 3. And we have our final answer, including restrictions. No need to expand the denominator. It's helpful to leave it like this. We expand the numerator to see if we can factor and then further simplify.